What's happening with the word problems? What happens with the word problem is that in this first one, they're giving you a template to follow through on. As you read through it, they're talking about buying books, and they're talking about earning points. So what happens here is that you have to just label them with some sort of a variable, X and Y, or in this case, they're talking about paperback and hardcover. So I'm going to use P and H. Okay? So it tells you that you order paperback at $6.95, earns you 2 bonus points. You order hardcover at $19.95, earns you 4 bonus points. Your first order comes to a total of $60.75, and you earn 14 bonus points. How many of each did you buy? Well, it's not saying you bought this plus this equals total amount. You have to automatically throw this into how much everything costs. So you know that you have 2 equations because they're talking about bonus points. So you've got paperback and hardcover for both of them. If you look at the bonus points one, what was the total amount of bonus points you earned?
14.
All right, how many points do you earn per paperback?
2.
And then the other one is?
4.
Okay. Now, on the other one, you're talking about total cost. I got scrunchy face, you okay?
Yeah.
All right. Total that you spent was $60.75. You agree?
Yeah.
All right. How much was a paperback?
6.95.
All right. Now, it's a matter of graphing. Well, we're not graphing anymore because it's a pain. Because these things don't line up real nicely on your grids. I'm going to solve this using a system of equations. And if you recall, in systems of equations, this is similar to what something looks like this. Remember when you had x plus y equals 8, and then 3x minus 4y is 12? Yeah. You do a linear combination, or in this case, can I get x by itself?
Yeah.
How? Good. So x is 8 minus y. So now we take this value and substitute in. Remember that? All right. Take a look at this second equation we have here. Can you tell me about 2, 4, and 14?
They're all multiple.
So they're all even, right?
Wait a minute.
So can I divide everything by 2?
Yeah.
All right. So if I do everything here by 2, so then can I say paperback is what? I'm seeing if you're paying attention. Good work. Yes. I can say that, right?
Yeah.
Now, in order to figure out what I can do is take this value here and substitute in. I did this on purpose by having you guys try to graph these things because it's a pain in the butt. I hope that you gave up on trying to graph them and just solve them.
Oh, we were supposed to graph.
Well, that's how you solve them. Did you just solve them?
Yeah.
That's fine. Good. Then you said, screw you, Murphy, I'm not graphing these things. Good.
Sorry.
No, it's all right. I hope that you did that. Okay?
Watching it tell me.
So now you wind up with a much easier thing. You have 695 times 7 minus 2h plus 1995,
Can you move this up a little bit or down?
and that equals 6750.
Thanks.
You're welcome.
A little more. Oh, there we go.
That's why I use it.
Stop it!
You wind up with that. Now, does everybody see how I have just one variable?
Yeah.
Distribute out and solve for h, and that'll give you your h value. Once you figure out what that is, you substitute back in here, and there's paperback. It's that much easier. I hope that you guys didn't try to graph those. If you did, great, but your windows were probably real nasty, try to get everything to fit, find out where they all wound up, and it's just a real pain in the butt with all the decimals.
Wait, graph them on a calculator? Graph them? Yeah, I did one.
Oh, that's fine. But this is much easier, isn't it? What did you guys get for this one?
Like, it's not like, because you can go
Hold on, guys.
second calculate, enter, don't you get what you need to get? The points?
Yeah.
So that's easy.
Yeah, sometimes though it doesn't line up real nicely. Sometimes if the intersection isn't shown on the window,
Yeah, then you change the window.
right, and that becomes a pain in trying to find it. That's what I'm saying. And what was your solution then?
I got 3, 2.
You guys get 3, 2? Anybody do this yet? I don't.
Wait, is someone left reading the column?
This is just showing an example of what substitution is. That's all.
Wait,
Okay.
is the, did that one or that one?
I don't know what this is. I didn't do it.
Yeah.
I'm guessing it's this one. Okay. And you use the same exact method when you talk about decoration costs or the floppy disks or the other ones. Which one do you want to do? I only want to do one more of them.
65.
I will do 65. Which one of these did you want to do?
All right, 55. 55.
All right.
55.
Sorry, I'm mad now.
You're going to prom. Yay! And you're in charge of getting balloons because you can't get a date. You want to use both latex and mylar balloons. Latex balloons are 10 cents a piece. Mylar are 50. You need 125 balloons, and you have $32.50 to spend. How many of each did you buy? Okay, so you need to buy some amount of balloons, but you know that the overall, how many balloons do you have to buy? All right, so we need to buy, I'm going to use L for the latex plus M for the mylar equal 125. That's the total amount that I have to purchase. In this case, I know that. After that, I know that each of the costs, 10 cents plus 50 cents. And once again, all I'm going to do is a system of equations. I'm going to let L equal, and substitute here. See what I'm doing here? Getting L by itself and using substitution. So I have 0.1 times 125 minus M plus 0.5 M is 32.5.
What's that little number?
That's a lot. It's point to like.
Yeah, you get 50 mylar, then how many of the others you have to get?
75. You have to pay 60.
What's that? How did you set it up? Did you? How did you set it up? You're on the right track.
Yeah, all right, just commercial. So instead of 4.0, it's 4.0. Oh yeah, it's insignificant. Insignificant 0.0, so it's ends up being 4.0.
Number 65. Number 65 is a trick question. Ladies and gentlemen. 65 is something that I hope you guys will start to do in real life. Try and find the best deal. One of the things that I want you to look at here is they're talking about something being 15% off. Do you guys know how to do quick calculations with your phone? If something's 15% off, what do you multiply it by?
0.85.
How much? 0.85, good. If you're going shopping to buy a pair of jeans and they're $20 and they're 15% off, you're not going to find your 15% of 20 and then subtract it from 20. You're going to multiply it by 0.85 to get the cost. You didn't know that?
No.
Seriously?
No one.
All right. Is
It's
this?
just a little chart that says 15% off this price is this. I'm like, oh, okay.
No, seriously, if you see something is on sale, it's 30% off, take whatever it costs and multiply it by 0.7 on your phone. There's your answer. You're done.
Wait, why is it 8.85?
Because 15% of 100, what's 15% of 100?
5. 15. 15.
15% of 100.
It's 0.85.
That's the multiplier. Alright, that's just how it works.
15% off.
Alright. So what you're doing here is that you know that the cost of the camera for one store was 15% off. So whatever that cost is, you take 0.85
Oh, I did that thing.
times that. And then the other one, it says the cost is going to be whatever the camera is minus $300. That value of X is, it really doesn't matter because it's going to be the same place, the same cost in any place.
Where do you put the
You don't.
That's just.
They're saying that you're assuming that the lowest price is $700 because below $700, obviously, you're going to be better off buying it someplace else. Because if it's yeah, if it's above. I'm sorry, that back should be 700 minus 300, X minus 300. Excuse me.
Come on. That's what I did.
So when you graph this, you're going to find out by moving your window around, it's way, way, way out there. Or since they both equal this, you have to figure out what they equal. They're going to equal the same amount. The overall cost is. Set it up. You get 300 is 0.15 x. When you divide that out, you get $2,000. Bless you. You get $2,000. So all you have to do then is figure out, okay, if it's above $2,000, that's like the break-even point for both stores. If it's more than $2,000, where am I better buying it? If it's below $2,000, where am I better buying that? That's what they're doing. Okay? That's what this does. This is called comparison shopping. This is something you guys probably will do. Okay?
Actually, I don't.
Don't ever buy anything without looking it up first. Ever. Because you will always find it cheaper. Seriously. You will always find it cheaper.
So are you saying I can't go to Aaron's and buy a TV?
If you go to Aaron's right now to buy a TV, you're going to be paying, all right, let's say the TV at Best Buy is $2,000. You go over there, Aaron's, for the next 48 months, you're paying $250 a month. That's a lot more than $2,000 in the long run.
But it's.
Yeah, good one.
What I'm saying here is those types of places, you could have gone back and bought it 3 times over the amount of time you buy it. You know, if you can't pay for it up front, I shouldn't be paid for it. All right. Obviously, there are certain things like you will have cars, houses. And one of the general rule of thumbs is you never put something on credit. You never finance something that's a depreciable asset.
Can you speak English?
Depreciate. What's depreciation?
Over time.
It loses its value. When something loses its value over time. So if you're financing something, that means you're paying a little bit towards it, and the unit could be depreciating faster than the way that you're paying it off. Unfortunately, it does occur on cars, it does occur on houses, things like that. I know we discussed this. See, this is like all-encompassing math class, isn't it? So I'm not going to collect this because I think I did enough of them. What I do want to do today is go into the next set. So when we get back into doing this stuff, we are... Now, when we're talking about solving systems equations, we just discussed in the word problems one method to solving systems. Substitution. Substitution is to solve a system of equations. You use substitution when a coefficient, what's a coefficient?
IDK. No say.
Number in front of a variable. When a coefficient equals 1 and can be solved by itself. For example, in this first one I have here, so we don't need, actually we don't need people. In this first one I have here, do I have the ability to get a variable by itself with ease? I do. Which one? Which x? The second. The x on the bottom here. Because there's no coefficient. Well, the coefficient's 1. Okay, in this case, the coefficient's 1, so it's very easy to get it by itself. So I could say that x is 2 minus 2y. Do you agree?
Yes.
All right. Now, from that, using substitution, I take this value here, and wherever I see an x in the first equation, what am I going to put? Right there. What are you guys going to mess up? You're going to forget how to distribute. You'll send it to one term and not the other.
Or you'll add.
Does everybody see how you wind up with a very simple two-step equation now? Everybody okay with that? All I did here, combine my like terms. I subtracted 6. So I have a value that y is 5. So now what do I do to find x? Are you doing electrical work?
Yes.
Substitute. There you go. You substitute back in, so x is going to equal 2 minus 2 times 5, otherwise known as negative 8.
Can you sub it into the original equation?
If you'd like, that's fine. But the only reason why I don't do that is right here when we're using substitution, it's very easy since we already have x by itself. It's just one less step. But yes, by all means, if you want to go to the original, go ahead. So now, when you're done writing systems of equations solution sets, you always write them in ordered pairs. Negative 8 and 5. And that's your answer. You can do that too, but it's just as easy. Okay?
Oh, like x and y.
Because what we've done is we've figured out where these two lines intersect. They intersect at the point negative 8 and 5. Okay?
You just do it
Magic.
Well, this is how you always leave your answer. Yes, sir.
So then, but then you could go into a calculator, you could solve for y.
Yeah, to double check it.
Find it in the intersection there.
Yeah. And what I'm saying here, though, is that when I say on a test or a quiz, solve algebraically, that's what I want to see. Okay? Now, the other method that we do with these things is linear combinations. And within linear combinations, there's a couple of different ways of looking at it. What you want to do with linear combinations is you want to figure out how to combine the two equations into one. And you can do that a couple of different ways. First way you would look at it is that you want to have same coefficient with same signs. If you have same coefficient and same signs, you can eliminate them by subtracting. And I'll show you examples here. And if you have same coefficient with opposite signs, you would add. And when I'm saying being very general here with linear combination, what you're going to have to do sometimes is it might not just look like a 3x and a negative 3x right above one another. It might be 3x and a negative 6x. You'd have to do some sort of multiplying, some factor work. For example, now what do? 2x minus 4y is 13. 4x minus 5y is 8. Why? If you solve for x on this, you're going to get a real god-awful looking fraction, aren't you?
Don't you just like subtract the top from the bottom? Couldn't you just divide by 4 on the bottom?
If you do that, but then you have to deal with fractions.
Oh,
don't. Let's,
So it's gonna be 2. And
yeah, you don't want to do substitution, guys. Do you see a variable by itself? No, don't do substitution. Use linear combination. Try to eliminate one of the variables. Pick x or y. What do you want to get rid of? X. All right. Notice 2x and 4y. What do you want to multiply one of them by to make it look like the other? Multiply the top one by 2. Okay?
Wait,
Yes, sir.
when you say same sign, what does that mean? Like sign?
Same. See how it'd be negative. It'd be 4x, 4x. I can subtract them out.
Yeah.
So what I'm going to do here by multiplying the top one by 2, I get the following: 4x minus 8y is 26. Everybody agree? All I did was just write it below it, and now I have a subtraction problem. 4x minus 4x is 0. Negative 5 minus negative 8 is 3. 8 minus 26 is negative 18. You've got to watch your signs. You got to watch your signs. This is the only thing you're going to screw up is the signs. All right? All we're doing here is we figured out by getting the same coefficient, the 4s, since they're the same coefficient with the same sign, in order to eliminate them, I subtract them. So I have to subtract the two equations together. That gives me 3y is negative 18. What's y? Good.
So if you can make the like equations into like
Yeah. Same thing now. In order to figure out what x was, you just substitute back in. 2x minus 4 times negative 6 is 13. 2x plus 24 is 13. 2x is negative 11. X is negative 11 over 2. And that's it. And that's what it's looking like. Okay. One thing you can do then, if you want to double check your work, substitute in both the x and y values into one of the equations, see if it's a true or false statement. And that's your answer. Okay? Remember, the idea here is to be able to eliminate one of the variables. You want to kick one of them out. In order to kick one of them out, you got to have either the same sign with the same coefficient, or same sign with the opposite, or same coefficient with the opposite sign. And that's how we do some eliminations. Let's look at another one. I have 2x plus 3y is negative 1. Then I got negative 5x plus 5y is 15. I'm going to do some sort of linear combination to get rid of them. Does it matter which variable I pick to work with? No. One thing I will suggest is that anytime you see opposite signs, work with that variable. You guys are better off adding than you are subtracting. Because remember that last problem we had negative 5 minus negative 8, it became positive 3. You guys tend to forget those rules. So anytime you have opposite signs, try to work with that right away. So if I'm looking at this 2x and a 5x, what would I have to multiply them by? Yeah, that's another way. There's about 4 different ways to solve this one. I'm gonna do the linear combination one first, and I'll go back and talk about what you just said. If I multiply the top one by 5, the bottom one by 2, you get 10x plus 15y is negative 5. Negative 10x plus 10y is 30. Do you agree?
I would agree with that.
Now you have same coefficients with opposite signs. How do you eliminate them? So add everything up. You get 25y is 25. What's y? 1. All right. No. In order to figure out what x is, you just substitute back in. 2x plus 3 times 1 is negative 1. 2x is -4, x is -2. That gives you my ordered pair. Now, what you were saying, -2. If you look at that second equation, are they all multiples of 5? They're all multiples of 5. So one other thing you can do, if you recognize this, you can divide them all out and get -x plus y is 3. Which means y is x plus 3, and just substitute right there. Either way, it works the same. What happens tonight then with the homework and all, I'm leaving it up to you to decide which method to use. What's that? Methods? Not really. I mean, if you look at the methods here, the linear combination really encompasses about three or four different things you can do. I just call it linear combination instead of saying with this method here, because I want you to be able to look at I want you to look at the values, look at the systems that you have, and make a decision on how to go. Okay? Look at one more here.
Drop it back in there. Wait.
Try that one. Try that one. Once again, in this problem here, what I'm going to do is I'm going to eliminate the y values. The reason why I'm eliminating y is because they have alternating signs. You can eliminate x if you want. Doesn't really make a difference which one you choose. I think it's easier to start with an alternating sign. Multiply the bottom one by 4. We have 3x minus 8y is 1. 24x plus 8y is 44. Now I have same coefficients with opposite signs. I add them together. 27x is 45. X is, was that 5/3? Okay? We did something wrong.
Oh, you're doing y.
I did y. Now when I go to find x, I go back to either equation, so I'll use the first one. 3 times 5/3 minus 8y is 1. Subtract the 5 over, I get negative 8y is negative 4. Y is 1/2. Been a while since we've worked with numbers like this, huh?
Dude, I remember this.
All right. Tonight, what I want you to work on is this is section, what is this, 3.2? Look at your book here. Thank you, sir. I think it's 145, I want to say. 153.